Notice we gave you so much less room, and that's because you've already done all the work. We already know about inverses, right? Inverses, we swap domain and range. We swap x and y. So really, all this information I already have. I just have to rewrite it. So first thing I'm going to do, just so we have it as a reference, I'm going to rewrite our original function up here because I've lost the space on my sheet. So here's our original function. First thing we're going to do, actually, I guess that's the second. Second thing we're going to do is we're going to graph the inverse. So remember, for inverses, we start by writing the function as y equal to, and then we swap our x and y's. So I'm going to put x on the left, and on the right, I have log base 2 of y plus 8 minus 1. So my goal is to solve for y, which really means I need to get y out of that interior. So I'm going to start by adding the 1 to both sides. So I get x plus 1 is equal to log base 2 of y plus 8. And then remember when we were solving for our x-intercept in the first problem? We're going to do exactly what we did then. Our strategy to get y out of that interior is to convert this to an exponential function. So I'm going to write this as 2 to the power of this whole thing on the left. I'm going to put it in parentheses, x plus 1. And then Ferris wheel all the way to the right is equal to y plus 8. So this guy is an exponential function. Actually, let's go up here. Will be 2 to the power of x plus 1 is equal to y plus 8. No more logs to worry about. That y is free as a bird. I'm super happy that I can solve for it. So to get y by itself, I'm going to subtract 8 from both sides. And that 8 that I subtract from the right, that's fine because the y ends up by itself. On the left, I do not subtract it from 2, right? Because the 2 is stuck inside or with its exponent. So I have 2x plus 1, can't be changed. That minus 8 just goes on the end. And this guy is my inverse. All right, now domain, range, asymptotes, intercepts. We don't have to do all the work again. We've already done it, right? So I'm going to zoom out so we can see this a little better. The domain and range for f of x, all I have to do is swap these guys. So, a little bit smaller, sorry. So my domain is actually, for the inverse, is going to be the range of the original function. And my range is the domain of the inverse. All right, my x and y intercepts. So my y-intercept at 0, 2, that becomes my x-intercept when I swap the x and y. So 2, 0. My y-intercept is going to be my x-intercept from the original. So that becomes 0, negative 6 when I swap. Asymptotes. So this guy is an exponential function. So what did we say earlier? Exponential functions have horizontal asymptote. Where do they come in? That value that we're adding or subtracting as a constant, that is the value of our horizontal asymptote. Horizontal asymptotes we write as y equal to. So my horizontal asymptote, y equals negative 8. Okay, let's put it all together. So to graph this, I start by graphing my horizontal asymptote. I am going to plot these intercepts. So 2, 0, and 0, negative 6. And then if I just draw the line kind of connecting, I can see the top part of the graph. And then remember, as always, graphs love asymptotes, so that's going to hug it, hug it, hug it. And that's it. So much faster than what we just did above because we've already done the work. So let's take advantage of that and make our lives as simple as we can.